Get ready to dive into the fascinating world of ocean research. We're about to uncover some incredible insights that will leave you amazed and curious for more. The secrets of kelp forests and their impact on coastal ecosystems are about to be revealed. In the remote Kamchatka region of eastern Russia, a team of scientists has embarked on a groundbreaking study. They aim to unravel the mysteries of canopy-forming kelps and their role in creating diverse and thriving coastal environments. But here's where it gets controversial. The environmental conditions that kelps thrive in have been largely unexplored in this region. Our researchers set out to understand the spatiotemporal dynamics of kelp forests in Kamchatka. By analyzing patterns and trends in kelp canopy, they compared biological parameters like chlorophyll A levels with climatological indices. The study utilized innovative data from Kelpwatch, a global dataset that maps kelp canopy area using satellite imagery. The findings revealed an intriguing spatial variation in kelp forest patterns. While the southern subregion showed a positive trend in canopy area, the relationship between phytoplankton and kelp dynamics suggested the importance of nitrate as a regional driver. A weak correlation was found between the Pacific Decadal Oscillation (PDO) and the Northern Pacific Gyre Oscillation (NPGO) across the region. But this is just the beginning. Understanding the regional patterns and trends in Kamchatka will contribute to a global understanding of kelp variability and its key drivers. The positive trends observed in the southern portion of Kamchatka warrant further investigation, don't you think? Now, let's shift our focus to the impact of tropical cyclones on marine ecosystems. Elevated sea surface temperatures, SSTs, in low latitudes are linked to more intense and frequent tropical cyclone events, posing a threat to coastal communities and fisheries. Characterizing ocean properties before and after these storms is crucial to understanding their impact. However, extreme conditions during tropical cyclones can make ocean observing a challenge. Cloud cover and surface disturbances often hinder satellite remote sensing of SST and ocean color. In this study, researchers combined satellite remote sensing with in-situ oceanographic data to assess changes in phytoplankton concentrations and SST associated with a tropical cyclone in the western Pacific. By comparing satellite observations with measurements from Argo floats, they validated the data and found that the typhoon passage did not produce a detectable chlorophyll A anomaly. The researchers further investigated the impact of the typhoon on mixing layers and nutrient concentrations, suggesting that while the mixed layer deepened, it was not enough to bring nitrate to the surface on a regional scale. This study highlights the need for continued multi-platform observations to advance our knowledge of tropical cyclone effects on surface ocean ecosystems. Next, we explore the El Niño Southern Oscillation, ENSO, and its impact on coastal upwelling in Peru's exclusive economic zone, EZ. ENSO is a powerful oscillation pattern in the tropical Pacific that drives atmospheric and oceanic variability on a global scale. Recent studies have revealed distinct differences in the spatial expression of SST anomalies associated with El Niño events. Elevated SST in the central and eastern equatorial Pacific, often referred to as El Niño flavors, have different impacts on global environments. This research investigates the relationship between El Niño variability and coastal upwelling in Peru. By analyzing satellite-derived SST data, the team aims to understand how El Niño events affect the highly productive fisheries and anchovy stocks in the region. Preliminary findings suggest that Modoki events result in less pronounced warming in Peru during El Niño peaks, with a delayed upwelling rebound response compared to eastern Pacific events. The subregional comparison indicates that the northern Peruvian EZ is more impacted by the timing and position variability of El Niño, likely due to its lower latitude and exposure to Kelvin wave propagation. These findings contribute to our understanding of how different El Niño expressions influence Peruvian coastal ecosystems, which is crucial for assessing ecosystem resilience and managing coastal fisheries. Moving on to South Africa, we explore the potential of synthetic aperture radar, SR, to map the distribution of canopy-forming kelp, Cyclonia maxima, or sea bamboo. Kelp forests are vital for coastal resilience and marine biodiversity, and accurate mapping is essential for their conservation. SAR data from Sentinel, 1, with its 5-day revisit time, offers a unique opportunity to observe kelp forest habitat even in cloudy conditions. Despite the potential of SR, there are fewer SR products for kelp canopy mapping compared to passive optical remote sensing. This study validates SR observations by comparing them with manually classified optical imagery obtained using a virus-NG, flown on NASA's Gulfstream 3 in 2023 as part of the BioEscape campaign. The research shows that SR observations can distinguish between kelp and ocean, especially in calm oceanic conditions. The sensitivity and responsivity of SR kelp forest retrievals depend on the tidal state during data acquisition. Lower tidal states support more accurate classifications between kelp and calm ocean water. Waves can obscure kelp backscatter response in SR data, highlighting the need for careful consideration of tidal conditions. By improving our understanding of SAR's utility for mapping sea bamboo extent, this study opens up future opportunities to enhance our knowledge of marine biodiversity and coastal resilience in the Great Cape Floristic region. Finally, we turn our attention to oceanic eddies and their role in energy transfer and biophysical interactions. Oceanic eddies are circular movements of water that facilitate energy transfer across multiple scales, influencing climate, ocean dynamics, and biophysical interactions. This research utilizes observations from the recently launched SWAT's Ka-band radar interferometer, (CARIN), to resolve submesoscale eddies and quantify their kinetic energy. By comparing SWAT observations with data from the DUAX project, which merges satellite data to observe mesoscale fields, the team aims to improve our understanding of the relative importance of the submesoscale in global energy transfer. Results demonstrate that SWAT supports the characterization of features at the upper bound of the submesoscale, providing snapshot opportunities to study ocean dynamics and energy cascades. While resolving the temporal dynamics of submesoscale features remains challenging due to SWAT's 21-day revisit cycle, these novel observations offer valuable insights. Future directions include coupling SWAT data with high-resolution numerical models or additional satellite missions like PACE to investigate key controls on biophysical interactions associated with submesoscale processes. And there you have it. A journey through the fascinating world of ocean research, uncovering the secrets of kelp forests, tropical cyclones, ENSO, SAR mapping, and oceanic eddies. Each study contributes to our understanding of the complex interactions between the ocean and the environment, and the impact these have on coastal ecosystems and communities. So, what do you think? Are you ready to dive deeper into these topics and explore the controversies and comments they spark? Let's continue the conversation in the comments section.